I'm Dr.A.Kumaravel, Professor and Dean, School of Building and Mechanical Sciences, K.S.Rangasamy College of Technology, Trichandur. I'm handling the course on finite element analysis. This is the beam, maybe cantilever beam. We dealt with only the axial load applied on the member. Okay, so this axial load is B. So this is in the X direction. Okay, so this may be in the X direction. So normally the definition for the beam is a structural member which is supported along the length, okay, which is supported along the length, see, which is supported along the length subjected to external forces or load acting transversely. This is the axial direction and this is the transverse direction. So this is transverse direction, the forces acting transversely, so that is perpendicular to center line, perpendicular, this is the center line of the beam. Okay, so you take the beam like this, okay, and so this is the center line, okay, the transverse load is acting perpendicular to the center line, so perpendicular to the center line. Okay, so the beam is sufficiently long, okay, when it is going to be called as beam sufficiently long when compared to the lateral dimensions. When compared to the lateral dimensions. You assume that the beam length is 1 meter. Okay, so the diameter of the beam is probably what is called 20 mm. Okay, 20 mm, that means 2 centimeter. The diameter of the beam is 2 centimeter. Okay, so you see that this is 1 meter. If it is converted into the 100 centimeter, 1000 mm. Compare these two dimensions. This is 1000 length. Length of the beam is 1000, and the lateral dimension, that is the diameter of the beam, is 20 mm. It is very small, okay, but it is very long member. So this is the definition for the beam. Okay, it is sufficiently long when compared to the lateral dimensions. Okay, if it is a rectangular member, you have to consider the breadth and width height of the beam. Okay, that also it is minimum when you compare with the length of the beam. This is the definition of the beam. So what are all the types of beams? What are all the types of beams? Okay, so if it is a rod, so it is a long lengthy rod. Okay, this is a steel member, we say that. So without any force or without any load or without any constraints, it is called as the structural member. Okay, it is a circular rod or rectangular bar. So like that, we can name it. So when it will become a beam, so already we have seen in the definition, it is a structural member which is supported by the load or forces, then only it is called as a beam. Okay, so now you take this structural member, okay, this structural member, one end is fixed. So one end is fixed. That means there is no displacement at this point. Okay, this type of beam is called as the cantilever beam. Cantilever beam. When it is called as cantilever beam, the structural member fixed at one end is called as the cantilever beam, whereas you see the other end is free. Other end is free. So it is called as the cantilever beam. Similarly, then you have the beam, that is a structural member, lengthy structural member. Okay, you have the support like this. You have the support like this. Okay, this support, with this support, this structural member is called as the simply supported beam. Simply supported beam. Here you see this is axial direction X. This is axial direction, yes. This is a transverse direction, y. This is a transverse direction, y. Here, in this point, the displacement in the x direction is 0. With respect to ux, or you take ux equal to 0. If it is a rectangular beam, then maybe there will be a transverse displacement also. Uy is equal to 0. Both the displacement are equal to 0. Free end, you have the displacements are allowed. Okay, so there will be a displacement, the transverse displacement also there, and the axial displacement also there. Okay, you see in the simply supported beam, the transverse displacement is 0, whereas the axial displacement is allowed if this is not equal to 0. So that is the difference between fixed end and simply supported end. Okay, so this end is called as fixed end. This end is called as fixed end. This end is called as simply supported end. Okay, simply supported end. So both the ends are simply supported, that is supported at the end. Okay, so this type of beam is called as simply supported beam. So then other one is you have the structural member. So you have the structural member like this. So this is second type of beam. This is third one. Okay. You have the support at this point. Okay, so this may be A, this may be B. Okay, so here also the A end is B. Here A, right, and B. The other support is not at the end, but it is supported from some distance from the free end. Okay, so like this. So this point is C now. Okay, you see that if this portion is not there, only up to AC, then AC is called as simply supported beam. But the beam is extended beyond the support. Some distance it is extended beyond the support, but there is no support here. Okay, it is a free end. So this is like overhanging. The type of beam is overhanging beam. This you may be studied in the strength of materials course. The type of beams. Once again, you can refresh it and remember that. So this is called as the overhanging beam. And you have the fourth type of beam. Okay, so this is a structural member. You see that this end is fixed now. This end is fixed now. So this beam is called as fixed beam. Both the ends are fixed. Okay. So this is fixed beam. And so other type is, fifth type is you have the structural member like this. You have one support here A, then other support here B. If this C means this is overhanging beam. Again there are some support here C. Okay. And here there is a support, this is D. There are many supporting this structural member. Okay, so this type of beam is called as continuous beam. This type of beam is called as continuous beam. You see that now the types of beams are, one is cantilever beam, looks like this. The second type is simply supported beam. So the support at both the ends, okay, where the transverse displacement only constrained, and the third type is overhanging beam. So beyond the support you have some distance, you have something like a beam is extended, but at the free end you don't have any support. So this portion is called as overhanging portion. So this type of beam is overhanging beam. Then fourth type is both the ends of the structure members are fixed, and this is called as fixed beam. And then fifth type is a continuous beam where the structural member have many supports between at the end and also between the support also you have the two or more supports are there. So this type of beam is called as continuous beam. Okay. So now you know clearly about the types of beam, and we are loading this beam with a different type of loads. Okay. That is, if you are applying like this kind of load, okay, this kind of load, then this is a transverse load. This is a transverse load. Already we have studied the axial load, the effect of axial load applied on the structural member. We have studied using the axial bar element, two-noded axial bar element. Now we are going to learn about the transverse load is applied on the beam. That means you have the lateral displacement. Whereas in the axial loaded member, you don't have the transverse displacement, only there will be an axial displacement. So that is the difference between these two type of problems. There we are using the element called as two-noded axial bar element. Two-noded axial bar element. This is node number 1, this is node number 2. Then the axial load is applied. The displacement is U1, displacement is U2, the direction is in this direction, this is X, only in the axial direction. Okay, so here we are analyzing the beam with the transverse loading. You have the lateral displacement and also you have some rotation on this, on the end, because of the transverse load applied on the structural member. So different type of beams. So here what type of element we are using is beam element. Okay. So beam element with two nodes. Okay, with two nodes. So what is the difference between the two-node axial bar element, two-node beam element? So two-noded axial bar element will be applicable to analyze the axial load applied on the structural member. Okay, so that is the behavior of the element. Okay, so beam element which will be applicable to analyze the beam with transverse loading. Beam with transverse loading. So here you have the displacement and you have the rotation. Rotation can be denoted as pi value. Okay, the displacement taken as the notation called d, and the rotation is taken as pi. Okay, so how to configure that? You see that this is the beam now. So this is the beam now, 200 beam element 1 and 2. Okay, 1 and 2. So what are the different type of load transverse load we are going to apply? First type of load is point load. Okay, so then you take the simply supported beam. So one load is applied here, W, at this point. Okay, so this is support A, this is support B, and C. At point C, you are applying the point load, transverse load. That means this is acting in the load is acting in the Y direction, whereas in the axial beam, the load is acting on the X direction. Okay, so this is lateral direction now. This type of loading is called as point load applied on the beam, point load. Then the second type of loading arrangement is, then you take the simply supported beam, uniformly distributed load with the unit load of W per unit length. W per unit length. So here in this problem, the total load is W. The total load is W. So here in the uniformly distributed load, you know that you have studied in the strength of materials course. So this beam length is L. So what will be the total load applied on the beam? That is the load applied per unit length, omega, into the length of the beam. So where the length of the portion where the uniformly distributed load is applied. So W into L. Okay. So this is the total load for the uniformly distributed load. Okay. So the third type is uniformly varying load. C type is uniformly varying load. You take this is a simply supported beam. So from here it is a 0 and then it is uniformly varying. Okay, so that means the load is applied like this, like in the triangular form. Okay, so uniformly varying, uniformly, that means it is increasing. Here it is 0, here at the end is maximum. Okay, so this type of load is called as uniformly varying load. Uniformly varying load. Okay, so now you know that three type of load is applied on the beam. So then we are going to analyze the beam structure for the displacement and the rotations. Okay, displacement and the rotations. We are using the two-noded beam element. Okay.